In question 2, the problem statement says, in triangle ABC in this figure, AD is the perpendicular bisector of BC. So AD, which is this segment, is the perpendicular bisector of BC. So we have to show that triangle ABC is isosceles, in which AB must be equal to AC. Okay, so because AD is the perpendicular bisector of BC, it's perpendicular to BC, so we have these two angles as right angles, and also it bisects BC, so BD and DC must be equal. Now let's compare triangle ABD with triangle ACD. So let me highlight these two triangles for you. So triangle ABD is this triangle. So it's always good to visualize the triangles which we are comparing, and keeping the order of the vertices correct. So triangle ABD, I'm comparing this with triangle ACD. So let me draw it again, ACD. So these are the two triangles we are going to compare, and clearly visually they seem congruent. What we have to do is rigorously prove this using some congruence condition. So we are going to compare triangle ABD and triangle ACD. So what are the corresponding parts which are equal in these two triangles? So clearly AD is common to both of these triangles. So AD is equal to AD, common. Also angle ADB, which is this angle, is equal to angle ADC, which is this angle. And why is that? Well, both of them are 90 degrees. So angle ADB is equal to angle ADC. Both are equal to 90 degrees. And also, because D is the midpoint of BC, because AD bisects BC, we noted that BD is equal to CD. And this is because AD bisects BC. Okay, so now what we see is that in these two triangles ABD and ACD, we have two side pairs which are equal and the included angle pair also as equal. This means that triangle ABD is congruent to triangle ACD using the SAS congruence criterion. So the two triangles are congruent, and this means that all the other corresponding parts are also equal. In particular, this side AB is equal to this side AC, and this is what we had to prove. AB is equal to AC, and hence triangle ABC is an isosceles triangle. So from here we can say AB is equal to AC using CPCT, and hence triangle ABC is isosceles. Okay, so that completes our proof. All we did was compared triangles ABD and ACD and proved that the two triangles are congruent using the SAS congruence criterion.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.